one thing which is very unique about our generation is that everything around us is getting connected. And the things which are not connected yet are soon to get connected. For the longest time, getting things connected used to be a very complex affair. Now, thanks to the advances in technology, that's getting simplified. But guess what? When we were almost done simplifying the infrastructure piece, this AI comes in, the AI workloads, and the demand for AI is unlike anything that we have seen in our lifetimes. So it's a major opportunity, it's a major challenge at the same time, and I'm so pleased to be joined by this an exemplary panel here to make sense of this complexity. So Senthil, if we can kick the discussion off with you. Now AI comes along, but our architectures, the way we used to think about networks used to be a bit more traditional. What are the changes do you see and what are the bottlenecks from your vantage point? You deploy a network at a humongous scale, 500 million plus. What are some of the macros that you are picking up?
Yeah, hi. Good morning and good afternoon all. From telco perspective, I would like to give my views on what are the advances that we are making. Okay, so first of all, this AI networks require, from capacity point of view, almost 10 to 100 times more capacity when AI is being enabled in the network. So my view is the cloud native or the old legacy networks won't be able to keep up with the current AI-driven network demands. So for that, one of the requirements what we are seeing in the telecom operator side is massive upgrades are happening in the day-to-day. This thing like our customers like CTS and all, they are upgrading the networks from 1 GB to 10 GB or 100 GB. So why these legacy networks can't able to gear up is because the legacy network generally does not fit the latency point of view also. And plus the traffic flow will be generally from north-south bound in the legacy networks. Whereas the demand which the AI creates is more on the east-west side, where the GPU communicates more with the server and the requirement of latency comes down to 10 to 20 milliseconds. So here plays a major role, wherein the operator's point of view, we have to shift to the edge computing and also keep the data centers close to the enterprise customers. So the massive upgrade is required. And the current legacy networks, we can keep it for their office use or the temporary, that lower end of works. But going with the, if you want to train your AI models, then we have to definitely upgrade the links at least to 10 times. And we, from Geo point of view, we are ready with all IP network. We have built up all IP networks and data centers. So this upgrade is being foreseen and we will definitely support it more and more going forward.
Fantastic. So Anand, now turning the discussion to you, and you have been involved in building some of the biggest backbones I think we have seen as a country, and as part of the national infrastructure as well. And there have been evolving usage of this backbone, right? I mean, first internal, but now increasingly you're commercializing this backbone externally as well. Where are the choking points from your perspective, based on your experience?
Good morning, all of you. We are having close to 64,000 kilometer backbone network across country. So earlier, the bandwidth capacity was one of the choking point or was the requirement. But now the performance and what I can say is latency and jitter. These two things has become more important. So the quality of network instead of quantity has become the key point for the current usage pattern or the current requirement. So these are the key points. And second is the tier 2 cities. The network in tier 2 cities is still, or tier 3 maybe, though we are having our network across country and maybe tier 3, 4 and all cities we are covering along the track. But still I see there is a gap in the quality instead of quantity, the quality perspective. Tier 2 cities are lacking in terms of the requirement. And though as we are moving into the AI era, so I think the more workload is coming from the users or agentic AI and other things are, it is the requirement may be moving to the smaller towns also, wherever there is a population. So the improvement in this network is also required. So yes, we are trying to fill that gap.
It's a journey. It's a journey, like you said. So coming to you, Vipul, the data center, probably, you have one of the largest footprints of laying it out anywhere. And a lot of the AI demand, I think, comes down to, where is that infrastructure in terms of the data centers? So from your vantage point, I mean, is it the core infra itself? Is it the interconnect? Is it the access to the latest GPUs? Which one do you struggle at times?
So, very clearly, today's bottleneck, what is the visible bottleneck? Every second or third player is running towards GPU because there is a shortage of GPU. So it's a visible bottleneck. But the invisible bottleneck is the underlying infrastructure. When I talk about underlying infrastructure, it is not just the network, but the power, the cooling, all the infrastructure underlying it. So you may create a massive GPU or AI compute, but the underlying infrastructure is not designed to support that massive AI workload. It is of no use. The performance will suffer, right? So traditionally speaking, nobody thought that or nobody planned for such a massive scale of network to support the AI workloads. But now is the time that everybody has to plan that. So I joined this company CtrlS 4 years back, and what I realized, so now we are very vigilant whenever we are building any new facility that we design the fiber infrastructure or approach to the data center right. Otherwise, you are spending crores and millions and billions of dollars of rupees on data infrastructure, the GPU, etc. It's of no use if the fiber infrastructure or the underlying network infrastructure is not supporting that scale.
Absolutely, absolutely. The core has to work first before we can, build bells and whistles. So now turning to you, Captain Naveen. I mean, all of this capacity is fine, infra is fine, but ultimately somebody has to take it to consumers and enterprises, and you have done some work, I would say, in that space. Where have you seen that challenge? Because enterprise these days, based on my vantage point, what they're increasingly asking us is, don't give me technical solution, bring it all together with the ecosystem and everything else, and solve the business problems for me. So from a broadband standpoint, how do you see this journey?
Thank you. Good morning to everyone. So traditionally, if you see probably about 20 years ago, the entire internet broadband was all about asymmetrical network with a lot of download. The priority was download. The way I see the bottlenecks currently would be, one is I would probably classify the entire bottleneck into probably three things. One is I would say that there's an upstream choke. So a lot of network today, our networks are not probably designed to, especially the edge access networks. They're not designed for heavy uploads. They're primarily for streaming our OTTs. They're basically made that way. We consume a lot of OTT. It's made that way. But with AI, there's an equal amount of live interaction that happens immediate. There are AI agents which is probably voice enabled, which requires a real-time response. I think so. Your upstream capability becomes important. It's important to upgrade the network. The current coaxial cables, which is there in the last mile, probably don't support. A Cat5 also probably won't support. So this is one. The next one, what I look at is the edge or the customer premise. So again, you may have a 1 gig network or pipe, but if your router does not support, then I don't think, we will not be able to do any of the real-time AI applications. A lot of people, a lot of startups, they take this SOHO connections, small home office, connections. It doesn't work. And also Wi-Fi itself is in a very, very unregulated environment with a lot of interferences that happens. Right? This is the second one. And third one, what I can think of is there are these micro bursts that happens. Sometimes when a customer writes a query, right? It might take a few minutes to process them, but there is a sudden burst of data that comes in, or probably a huge image or a video that comes in. then that chokes the network. Then, your traffic gets queued up, and then that chokes the network. So I think these are the couple of things that these are the strains, so these are the problems which I see which we need to address at this point of time. Thank you.
Thank you. So now we understand the challenges and the bottlenecks. Is every stack of the layer, the data center, the interconnect, the last mile, going all the way to the router. Let's change the focus a little bit about architecting for the future. And I think there's no doubt in anybody's mind that the biggest demand driver is AI, increasing all kinds of evolving AI workloads. So Senthil, bringing in an operator perspective again here, right? Because a lot of what you do in the telco world is really invest today for a use case which is going to emerge maybe 5 years later. So there's a lot of advanced planning, and you have to think through the operations so much in advance. So talk to us, what are the things that you keep in mind when you're architecting, when you're thinking about the network planning and the operations for the future? What are some of the things that you keep in mind?
Yeah, that is a very important thing which is going on. Like you said, to build the requirement of the enterprises, we have to start building like 1 or 2 years before itself so that we can cater to it. Yeah. So coming from the telco perspective, to start with, the network capacity planning will become a major overhaul. We foresee a major overhaul happening in the capacity front. Wherein the legacy network, if you put it in simple terms, is just like a railway track. We have put a track, the train runs as per the schedule it goes. So there is, if you want to shift the track, there is no place. You need to wait for months to change the tracks. Okay. Whereas the capacity planning of the future networks is based on intent-based networking. We call it as IBN, and also based on 5G slicing. So from geo perspective, we are the first operator in Pan India to have the 5G SA network architecture. So wherein we could provide individual slices to the customers or the end users. So no more we can just like offer a fiber. Okay, 1 GB customer asks, we cannot give. Okay, so because the latency requirements change. For example, a robotic arm company may require URLLC splicing. So which gives so for example, the robotic arm company, they need a latency of less than 5 to 10 milliseconds. So we offer this using network slicing called as URLLC, ultra low latency. And for example, if an IPL streaming match is going on, then the customers will be using eMBB. So that will go on a different stream. So this sort of slicing is going to play a major role. And Jio is the first operator to give a slicing, implement it, and give it in a wide scale in Pan India. I think more of the customer's point of view or SMEs, they would have seen it as Air Fiber and Air Fiber Plus. So this Air Fiber, which the operator gives, is basically based on the network slicing. So going forward, we foresee a lot of more splices happening, wherein we create elastic splices with the elastic capacity we create, and the end user enterprises team decides whether they want to use what sort of latency requirement. For example, zone A may use URLC, and zone B just they want to use for office traffic, and zone C may use for just streaming traffic. And from operation perspective, from telco operators, the network engineers use actually, for example, the old type of pooling involves SNMP, where every 5 minutes or 15 minutes, the operator gets a KPI report and then sees what is happening there or not. That is no longer going to be valid in the future world. So we have to move to the streaming telemetry, wherein the live streaming data, which is being sent back within 100 milliseconds of interval. So before there is a capacity choke happening, the AI will detect it and reroute the traffic in the other directions. Yeah, these are the major thing, and resources as well, like just one point. On the resources front, that could be key thing for many of the guys sitting around and from network engineers perspective. So what we foresee is the network engineer will not be only a network engineer, app and the end user getting merged. So I am not saying that the engineer needs to learn ML code or nothing, but they need to be aware what AI is doing in the network, so that they can stop it and overrule it when they go for it. So these are the two major changes, and we are already almost there, 90% I can say. So and it is ongoing, evaluation is ongoing. Thank you.
Yeah, I mean, having worked in network slicing about 3 years back for a Spanish operator, I know how hard that can be to implement that end to end. So Vipul, now we heard about the network architectures, intent-based design, things like network slicing. If you overlay and do a complement on the data center design side, how are you guys preparing for future? What are some of the new techniques that you are thinking through to be more ready for the workloads of future?
So it's very simple. Gone are the days when data center was a separate design, separate conversation, and network was a separate design and conversation. Now, in today's arena, we are talking about the AI world, so-called AI world, though we are still evolving. Network and data centers are not separate conversations. They are part of the same boardroom conversations because they go hand in hand. So all our data center which we are designing, those are network ecosystem ready and AI ready, compute ready, everything is ready. So it's not about designing network in silos or compute in silos, but it's about designing a AI ready foundation. Now, we can have a best compute in the world, right? But it is of no use if the underlying connectivity, power, cooling, infrastructure is not designed to support that huge compute or GPU.
Absolutely. All right. So Captain Naveen, now coming to you, from a broadband perspective, I mean, you already alluded to some of it, the router being the choke point. What are the innovations, if you can just maybe touch upon maybe a couple, how you're thinking through that, breaking that kind of bottleneck to prepare for future?
Yeah. So, like I said, traditionally, our entire network was built for a throughput of 80 to 90% of download, right? That's how it is built. So, what we usually do is, I mean, now the network architects usually are working aggressively on doing a couple of things. One is upgrading the infra, like some of those points which Sandeep also touched upon, right? And the second important thing, what they also do is we're working on upgrading the infra, right? Upgrading the 5G, like for example, if there are standalone towers, right? 5G towers, these are proactively upgraded. They do not wait for a choke to happen, right? And also what happens is, apart from this, there are systems, there are operators, for example, now, like when you do a OTT, you have your peering and caching devices which are closer to the your data centers, your regional data centers. That is something which proactively now there are companies which they are getting some of this AI caching servers. So something called a deep peering. Okay, they get it closer to your data center. That way the speed also increases. There's a low latency. I think these are some of the actions that is done at a network level to improve our interaction with the AI and make it faster. Yeah.
Wonderful, wonderful. So we spoke a bit about the constraints and how the architectures and the approaches are evolving. Now let's focus a little bit on the go-to market. Because at the end of the day, we can all be builders and take a lot of pride in being the engineers, who is inside us. But end of the day, it has to make sense for the customers, for the ecosystem out there. So Anand, now turning to you, for the longest time you have built this internal kind of capability infrastructure layer, and now you're taking it to market, right? How do you see the ecosystem play evolving? Because I'm assuming that you're not taking it to market entirely by yourself. You're really collaborating and you're offering services to newer set of players. How do you see that ecosystem coming together for you?
Yes, I think with the exponential growth because of AI and the use cases around AI, collaboration is the key, and I think we started collaborating in the broadband arena in year 2011, and we collaborated with the local cable operators to deliver the broadband. Later on, the same model was used by everybody. I won't name the telcos, but everybody used that model to build the network and serve the users. Ultimately, users has to be served. The model helped to serve more number of users to bridge the digital divide. And with one more initiative of Railtel, while collaborating with the Google, we provided Wi-Fi in the railway stations to, again, to bridge the digital divide, because most of the users access the Wi-Fi through that network. So how to, so again, with this, the exponential growth, we need scalability, and we need more close coordination among telcos, infra providers, and hyperscalers on the cloud providers. So we, the same way we have started collaborating with our partner to build new data centers and plan connectivity in such a way to help cloud providers or hyperscalers to serve or to fulfill their needs. And what I can see that in 2005 to 2020, the network growth was actually only linear or incremental. 2020 to 24, it was, I think it was multiplying 1, 2, 3, 4. But after 24, I see it as exponential. 1, 5, 10. The requirement is growing like this. So the planning is again a very important part, because if the network you are building today or infrastructure you are building today may not serve maybe 3 years later, then again it's a regular job. So I think this time we have to put more focus on the planning part so that we can serve the market, because all the infrastructure is choking as of now, I think, in terms of network also. Yes, everybody, each telco is building the network. Each data center provider is building data center. But still, the gap is not filled. As he said, my co-panelist said that bandwidth or the connectivity has to be planned hand in hand. So yes, everything has to be planned hand in hand to monetize it. Otherwise, if one part is ready, another is not ready, then certainly the capital is choked, the resources are choked, but it is not being utilized.
Of course, I mean, everybody has to work together. So, Senthil, now you will, and I've worked with another telco in my past life, so coming from that experience, and I'm sure a lot of your experience, you know, the partners that you work with these days, including hyperscalers, you know, in some cases you're cooperating, in other cases you're competing for the very same set of customers. It's not an easy relationship. I mean, there are multiple dimensions to that. You know, how do you see that evolving, not just with hyperscalers, but, you know, more AI native players coming in? You know, everybody is, end of the day, after, you know, same enterprise customers. How do you see yourself evolving into a framework where you're co-creating, you know, along with all of these partners? Just give us a bit of the journey.
Yeah. If you see earlier, the way the hyperscalers and telcos, they were handling just like a normal relationship, wherein hyperscaler just gets the bandwidth from the telcos, and telcos will just use their cloud. So this was the earlier things which were happening, and now this has been changing into in a terms of co-creation. This is being changing into a joint innovation partnership model. This is what I foresee, wherein like our both the cloud hyperscalers as well as the telcos are trying to innovate the data centers into their own networks. Like for example, telcos are upcoming with their own data centers. For example, from Geo perspective, we have our own data centers at Jamnagar and Nagpur, and we as a hyperscaler we collaborate with Microsoft Azure and in fact other players also, and we offer it as a full-scale end-to-end package for the enterprise customers. This is no more going to be silos. like a hyperscaler cannot just alone go and address the market of the enterprise team. They can't definitely. And even telcos, they can't work in silos because their 5G monetization is under immense pressure. They can't do it. That is the reason where you can see, like, for example, Gemini AI being offered as a package. Microsoft Azure is offered as a package. This will be like very much lesser than what the customers get when they go with an individual this thing. So in fact, we call Geo and GeoBrain and other platforms as a hyperscaler. We are already projecting ourselves as a hyperscaler, and even some hyperscalers are trying to project as end-to-end players. So this is definitely a very big co-creation happening with a joint innovation partnership, and that's the reason why we are tied up with Meta, Google, Microsoft, and all the things. So even they are like both in a handshake model currently.
It can look very complex, but underneath all of it comes together. That's the beauty of it. So we heard all three dimensions. We looked at the challenges, we looked at the evolving architectures, and then also how we are taking it to market. Which now brings me, and it's a complex topic. We can keep going on and on, but I just want to conclude on something very simple. The whole premise of this panel discussion. So I think it's established the fastest growing thing, the fastest rate of innovation now is happening in the AI. Right? So AI innovation is kind of setting the benchmark for all of us. Now the question is the enterprise connectivity, and Captain Naveen, maybe we can start with you. It's the same question I have to all the panelists. Do you think enterprise connectivity will be able to evolve in next 5 years at the same pace as we see in the AI innovation, or you see a risk of infrastructure really becoming a risk for the growth? Starting with you, Captain Naveen.
So it's again, it's a very, there's this thing which I read, right? Very interesting statement. I think from one of the Ericsson or some website, right? It says, AI needs network needs AI, right? So I think it goes hand in hand, right? So I think so what I would say is, it is how effectively the network service provider, the operators, adapt AI in making it more effective. For example, I will take just you one or two examples. Now, for example, now, like I said, the traditional models of, once upon a time when we used to stream videos, it used to take a lot of time because it used to go to the centralized data centers and come back. Then people figured out about the caching and peering at the local. That made it fast. Today, we are talking about those AI servers which are again placed in the local. That makes it fast. So you need to adapt to the infra requirement. The next important thing was to make the home devices more intelligent, probably move to Wi-Fi 7. We're talking about Wi-Fi 7 now, where the home devices become more intelligent, where there are various bandwidths where you can, where the current AI can route the traffic according to the requirement of the home devices, right? And the third one is in terms of the way we integrate with the network. So I was also talking about you, Sandeep, how today all of us go and want to lay out fiber network is very, very important, right? And the infrastructure, data center infrastructure. What happens is many of this fiber network and data center is limited to one person. There's no sharing model, right? The moment we get into a model where we collaborate and work, that speed to market increases and your reach also increases, right? I think these are the couple of things, if done, I think we could catch up with the AI, or we would be, lagging behind. And in terms of adopting to some of the AI, like we are talking about your automated AI agents, which can identify the problem and route the traffic to the right or the most optimal network. So which means the experience, end user experience will be much better. So I think a lot of these adoptions, identifying the problem, adopting them in time, I think would reduce or will make sure we don't lag much behind. Yeah, that's
It's a nuanced answer. No crystal ball yet. Senthil, very quick, your perspective.
Yeah, I think, as our co-panelist said, it will going as a hand in hand. Both our telcos and enterprises need to have that ecosystem ready. So though telcos are the first to prepare, I think enterprises are also getting prepared. And I foresee that both this fiber network and the enterprise requirement of cloud and AI training, large LLMs are a main requirement going forward for the customer point of view. So both are evolving hand in hand. I think we should well evolve together as a co-creator and definitely deliver for the customers. Yeah.
All right, so optimistic picture. Vipul, your perspective.
I think AI workload or AI demand is like evolving like anything. And the network infrastructure is not built for that, and it is not catching up. But it will catch up. Obviously, it will catch up because there is a lot of emphasis on the underlying network, not only in India, globally. Now, how do we catch up? So, underlying infrastructure like data center, terrestrial fiber networks, submarine cables, as data centers need to be announced and declared as a national critical infrastructure, not just telecom infrastructure or the data center infrastructure, right? So just one last, I'll summarize in one line that the winner is not going to be the one who is having access to the massive compute or GPU. The winner is going to be the one who can move data faster, smoother, and predictably. Thank you.
So you're cautiously optimistic. I like that. So we'll end with you, Anand. Your quick perspective.
Still in India, we don't see a wired network, whereas wired network is required by the users. And we found a workaround. And we are one of the largest population who's having access to internet using a wireless network. So I see there are a lot of challenges in terms of network availability or network reach, as well as power, as well as the data center requirement. But again, I think we will find some workaround and we will catch up. Some will catch up, some may be left behind, but there will be workaround to solve this problem and we will not be left behind.
Future is bright. No, wonderful. I think that brings us to a close. I really want to thank you. Wonderful insights, and you summed it up in a very simple way, which is always a challenge with our domain. So thank you so much to each one of you, and thanks for being the wonderful audience. Thank you, folks.